Welcome back. As you know, I am Eli, the computer guy, and in today's class, we are going to be creating an IoT messaging device using a Raspberry Pi and a Blues IoT modem. Well, you might be sitting there going, wow, that's a lot of words that I don't understand. I wonder what the hell Eli, the computer guy, is talking about. Well, for the past few classes, I've been creating projects with the Blues IoT modem. So basically, what this is this is a modem that connects to the LTE network, so essentially the cell network, and you're able to send and receive text very specifically formatted in JSON. So, anyways, we did a couple of classes where I showed you how to use this with their dev kit, which is basically an Arduino code, a clone, in order to do things such as send GPS locations back so you know where the item is. Think about using that for something like field technicians so that you can track field technicians when they're going about their jobs. And then I also showed you how you could send commands to that IoT modem to turn on a power relay. So basically, we used a system so that we were able to turn a light on or off, and that could simulate any number of things that you could turn on or off, essentially with a switch. So think of air conditioning units, dehumidifiers, water pumps, any of that type of stuff. So we were doing that with Arduinos. The thing is with Arduinos, they are microcontrollers. They're not computers. And basically, you give them commands and they just loop, 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 loop with very basic commands. And so for the following projects, basically what I decided to do is connect our Blues IoT modem to a Raspberry Pi so we get the full power of a computer. A Raspberry Pi is an ARM-based computer. I'm using a Raspberry Pi 4 for this particular project, and it's a quad-core processor with 4 gigs of RAM, a full Wi-Fi stack and all that kind of thing. You actually install VS Code onto it, and you get all of the power of Python. So instead of dealing with the Arduino IDE or the platform I/O system, you're actually able to deal with Python, which is absolutely lovely. So, anyways, what I have done here is I've created a system where on my main computer, I am able to send a message through an HTML form that goes up to Blue's API platform, and then this device will then download that message. So, imagine if you wanted a very inexpensive messaging system, again, for your field technicians. So, smartphones cost a lot of money, data plans for smartphones cost a lot of money. So, the cool thing with Blues is you buy the modem for like $60 plus a couple of other fees, but you buy it, and with that, you get 500 megs of data that you can use for up to 10 years. So you only pay for the data that you need. Once you burn through 500 megs of data, then you simply pay another $10 for an additional 500 megs of data. So instead of paying $5 a month or $10 a month or $50 a month, basically for the connectivity, you just pay $10 for every 500 megs. And again, since you're only dealing with text formatted in JSON, 500 megs actually goes a long way. So imagine, again, for your field technicians, if you had a computer device in their vehicles and you were simply able to send messages to them for whatever is going on. So basically, if you need to basically send a text message, essentially say, hey, make sure to pick up the invoice while you're at the client's house. This system would be able to do that. Again, imagine being able to do things programmatically. So I talked about that before, where you could create a server system that's constantly looking for things like weather reports, disaster declarations, that type of thing. And if it saw that your people were in the area of a storm, a tornado, that type of deal, it could automatically alert them of the fact. One of the things I think about, having dealt with construction people, I had a lot of construction done on my last house, which was miserable, absolutely miserable. But anyways, one of the interesting things I found with that is that many times they would be working all the way up until it started raining. And then my house would get wet because it got rained on. So imagine if you had a little system like this, just to be able to beep your field people, your construction people, to say, hey, a weather event is moving through in 30 minutes, so seal up the house now before we have to pay for damages when the house literally gets rained on, right? That's the kind of thing that's very interesting about this kind of system here. So basically with this, right, this is simply communicating with the LTE network. Does not use TCP/IP. LTE. This is communicating with the LTE network using Python and the Bottle web app framework to be able to grab the messages that are sent to it and present it onto the nice little screen like this. So this is what we're going to be showing you how to build today. Danger, Will Robinson, danger. I'm gonna have a massive trigger warning for this particular class because the Blues modem actually works really well on the Raspberry Pi. So one of the things when you come here for me for education is do realize I don't get sponsors. Blues is in no way, shape, or form paying for any of this. I've actually had to pay for all of this, including with the brain cells that I've lost. One of the things I was talking about in the previous class is using the Arduino clone dev kit that you're supposed to start with. That sucked. Their dev kits. I hate their dev kit. Oh, it was painful. You can watch the videos. I literally sped up the video for how long it would take for that little dev kit thing to actually be able to get messages and that type of deal. It's interesting. DevKit is definitely curious. One of the things that I'll say though is I am excited. I'm interested in what Blues is doing, so I decided to purchase the hat, basically the connector for the Blues modem to a Raspberry Pi 4, because my thought is again, sometimes overall systems are pretty good, but individual products suck. You've probably seen that before, and so I was like, well, I believe in what Blues is trying to do. I do not believe in this crappy ass dev kit. Let me try a Raspberry Pi hat. And I have to say, using a Raspberry Pi hat, then being able to use Python to be able to interact with a Raspberry Pi hat, this works like a dream. This is wonderful. Again, it's still quirky. They're still really too focused on JSON, but that is very manageable. Basically, working with the hat from almost day one, everything works pretty well. Not too many quirks there. So what I would say is, again, if you're interested in this whole Blues world, definitely think about getting a Raspberry Pi and a Raspberry Pi hat in order to learn this stuff, because I find it works actually great. Now, one of the quirks is with this whole system, you will notice I'm literally powering this off of a little USB battery pack. This is actually a touch screen. This is a touch screen. The Raspberry Pi is connected to the back, again, with the Blues modem. I will say, if you plan to do this exact setup, there are some weird voltage issues because surprise, the voltage that comes out of a USB battery pack might not be the best. So having this system this system here works perfectly. And as I do the demo today, this is simply what I'm going to be showing you. I will plug in a keyboard and mouse just so I can interact with it a little bit. But this is what I'll be showing you. I will warn you, though, is that if you do try to go to like normal websites like CNN.com or YouTube, because of the voltage issues, like going to those websites, I guess, require more voltage, and then this whole thing just starts getting quirky. We'll call it quirky really quickly. So do just be careful of that. I bought this, again, the screen for about $50 off of Amazon. It's pretty generic, basically a touch screen that you can buy for the Raspberry Pi. Generally speaking, if you're running command line tasks, if you're running your own little web app running on it, that type of thing, the power works fine. Again, when you start to do things like YouTube, it just starts blinking and having a little hissy fit. And when I say that, that's actually not just simply off of this little USB battery pack. Even when I connect a Raspberry Pi official power supply to this thing, it acts a little quirky. So again, this is one of the things I talk about in the world of IT, where sometimes, or for certain situations, products can be amazing, and for other situations, they can suck. This particular product is amazing for when you want to use it as a Blues IoT messaging system. But if you want to do, watch YouTube videos, well, and that'll be quirky. That'll be quirky. So anyways, with that, let's dive in. Let me give you a demo of what we're doing here, because I think this is really, really cool. Okay, are you ready for coolness? Are you ready for geek sexy? Let's do this demo. So this is actually running on my local computer. I'm using the Bottle web app framework with Python to run this web app on my local computer at 127.0.0.1 port 80, and this is basically just an HTML text form. Here I can go to this HTML text form and I can put in a message. Hello world from the class I am doing for my students, right? There you go. Nice little message there. I can now hit submit. That has now gone off. This is the NoteHub API here. We can see the message went to the NoteHub API, and we can see already, I don't know if you can see that, already by the time I've said that, that message has then come to our little IoT messaging device. And again, what I'm going to be showing you with the code today is how this kind of thing could be done programmatically. Again, you could have a server that's constantly doing API calls to weather, natural disasters, can be doing all kinds of different things. And basically, when it sees something of interest to your people out in the field, it could then very easily send a message to them. And this is a way to have communication that will be more reliable than normal like LTE communication. Like with smartphones and things, a lot of times if the bandwidth isn't good enough, right, you can't even open up a website. The nice thing here is you're just sending JSON, so it'll probably be more reliable. And again, as I said before, it'll be a hell of a lot less expensive if you simply need basic communication services. Now let's take a look at this hardware for just a second. There's not a whole hell of a lot to this. So again, I went on to Amazon and I bought myself a very generic $50 touchscreen that allows you to connect a Raspberry Pi directly to it. This is kind of cool, again, with these IoT projects, is go out and actually do a search for things like screens specifically for your Raspberry Pi 4 or Raspberry Pi 5 or Raspberry Pi 3. Find the one specifically for your Raspberry Pi, because many times it'll actually have screw holes so you can actually screw it all together. So like with this screen, I could connect a normal computer to this screen, I could connect a Raspberry Pi 5 to this screen, the whole 9 yards, but obviously I can't necessarily screw it directly to the back. So the cool thing here is we actually have the Raspberry Pi 4 screwed directly to the back of the screen. From there, basically there's a couple of connectors that go from the HDMI output on the Raspberry Pi into the HDMI input for the screen, and the USB output into the USB input for the screen to give you that touch capability. Past that, there's the note carrier. So it's a $15 hat from Blues that you plug into your Raspberry Pi 4 or 5 or whatever else, and then on that you screw in the modem. So again, the modem is its own thing, costs like $60 for the modem itself, plus the Raspberry Pi hat, so this thing called the note carrier, which is an additional $15, and then you have the Raspberry Pi, and then you have the screen. And with that, you get this pretty nifty, neat device right here, which again, I just think for any number of things could be very useful. Again, like right now, we're doing a messaging app here. So again, imagine field technicians out in the field being able to send them essentially text messages, but you could use this for digital displays. Imagine if you have digital displays in a campus, or again, you have a large facility that's geographically spread out. Let's say you have digital displays throughout that facility, and you're thinking, how can I have messages show up on those displays? So you may put a solar panel on it, put a little battery pack on it, again, because this doesn't need very much power. But then how are you going to deal with the connectivity? Do you want to pay $10 or $20 a month for real LTE connectivity? Do you want to make sure the Wi-Fi can actually get out there? What's cool with this is you could have digital displays that you can update from anywhere, simply connected, again, using this Blues IoT modem. So anyways, and this is the hardware and basically how it's built out. Again, it's pretty good, except for that weird power problem. And again, that might be like with the screen that you buy. I just found a random screen and bought the screen. So depending on what screen you buy, it may or may not have the power issues that I'm running into. So now let's talk about architecture. How does this overall system work? So I tippy tap type at my computer, and that message shows up on my IoT messaging device, but how exactly does that happen? Well, the first thing to realize with this system is that we are not actually using a server up on the internet. Again, when you create something like a web app, you don't necessarily have to put that web app up on the internet, depending on how it's doing communication. So our system, when I go to that little text area box and I hit the submit on the form, right, that is simply sending data out to the API that Blues has. It's not not receiving any communication back. So the cool part about that is we can actually just have that on our computer or server internal to our network because we don't have to have basically back and forth communication connectivity. Basically, Blues, right? Blues has their API up on the internet. They use a system called NoteHub is their platform, notehub.io. And so basically what we're going to be doing is we're going to be communicating with that API from our computer. Our computer has Python. Our computer has a Bottle. So Bottle is my current web framework that I like. It's really easy to use. Basically, you can just write your code, you can hit run, and as soon as you hit run, your web app is live. You don't have to go through anything else. So I think it's very useful for these kind of education processes. So anyways, here basically, we got a nice little text box and we got a little submit, and I'm going to put information in, right? So I said I put in the message. So basically from here, what's going to happen is first we have to get something called an OAuth token. OAuth. So whenever you're dealing with APIs, basically they decide how the authentication works. Again, a lot of times I get with like new coders, and they're like, "Why do you use OAuth versus something else?" And it's like because they require you to use OAuth. That's how it works, right? So anyways, OAuth is a token-based system for allowing people access to resources on APIs. And essentially what happens here is your computer goes up to NoteHub's OAuth server and it gets something called an OAuth token. That's the first part of the communication process. Once it gets the OAuth token, it then takes that OAuth token number as a token number. It combines the OAuth token with the message and then sends all of that up to the API, and that is when the API will accept that, basically accepts the credentials and the message, and so it gets stored into the API. Then over here we have our device, right? So we have our screen, we have our Pi, and then we have our Blues modem connected to all this. Now, important thing to understand with this is that the Blues modem is its own subsystem. So many times when you're doing coding or you're building projects, your code will be able to interact directly with the resources. So think about this like with a Wi-Fi card or a network card, right? In Python, you basically simply do something and you're able to do whatever it is that you want. The interesting thing here is your Python script, right, actually has to communicate with the Blues modem. And it sends a command to the Blues modem and it says to the Blues modem, hey, get a new note. So in Blues world, these are called notes, basically a message. Get a new note, synchronize with the API and get us the new note. Once that new note comes in, it's actually stored in the Blues modem initially, which is kind of an interesting thing. Again, when we think about things like security policies and where data gets stored and cached, and if somebody snags something when they weren't supposed to. And anyways, it actually gets stored within the Blues modem. Once it's in the Blues modem, then your Python script can then ask for that message to be pulled out of the Blues modem so that it's able to do something with it, right? And then it actually has to tell the Blues modem to delete the message. Again, one of the interesting things from a cybersecurity world is think about this. The Blues modem does not delete messages until you tell it to. So if you had lots and lots and lots of messages coming in, again, for your system, authentication messages, whatever you're doing, if somebody literally stole that modem and you hadn't sent the command to delete the messages, they might be able to get whatever messages that have been sent between the devices. So this is, again, one of those things just to consider. So anyways, you got the Python script. My Python script basically loops every 5 seconds. So just to make the system work, pretty quickly, unlike the last example, I just have a loop basically every 5 seconds. I don't know if that's a great idea in the field. Again, what you do as a demonstration versus what you do in the field might be entirely different. If I was in the field, I'd probably have it loop every minute or something like that, but we're just doing it for 5 seconds to make it quick. And so basically every 5 seconds, it's saying to the Blues modem, please synchronize. And once you've synchronized, give me what messages that you've gotten, right? So basically every 5 seconds, it goes out into the LTE network, connects with the Blues servers, and then it pulls down whatever it has. Once it pulls down the data, basically once it's pulled down the message, one of the things you have to think about is the data stored. Is it simply good enough to have the current message show up on the screen? So one of the things you'll notice here is if you take a look at my device, I can scroll up and I have all of the junk messages that I've previously done. over the last little while, right? It's got a nice little time code and ID and all that kind of thing, right? Because again, I don't simply want the old message to be deleted and the new message to replace it. Again, if we're having like a little conversation or something, I want to be able to see that history. Well, in order to have a history, you need to store to a data store. You need to store somewhere. So basically what happens here is once Python gets access to the message, it then sends that message to SQLite. So again, my second new favorite toy. SQLite is a very easy to use relational database system that basically is as easy to manage as a text file with all the power of a relational database. You get SQL, structured query language, right? So basically what happens here is a script grabs a message, stores it in the SQLite database. Once it's stored in the SQLite database, it then does a select all. So basically it selects all the records in that database, takes all of those records, and then prints that out onto the screen as all the messages that you have previously seen. It writes that as an HTML table. So again, that's why there's adequate formatting when you actually look at the screen, and that's what presents the message app to you. So this is the basic architecture of how this works. We have Bottle and Python on my local computer. Again, it's just a MacBook Pro computer. It's just a normal computer, but because we use Bottle, we're able to have that web app framework. We put in the message, we get the OAuth token, we send the message in OAuth token up to the API. Our Python script is constantly looping every 5 seconds, making a request of the Blues modem to be able to pull down any messages. When a new message comes down, that then gets stored into our SQLite database. Once it's stored into the SQLite database, we do a select all. Basically, we select all the records, and then we write all of the records onto that HTML document so that we get a nice little message screen like this. And so, this is the architecture of this particular system. So now let's take a look at the code. The first thing that we're going to look at is our quote-unquote server. Again, my MacBook Pro. So this is the code that gives us this nice little HTML form here. So when we take a look at this, we've got a couple of modules that we have to import in the beginning. So we have from Bottle. So again, Bottle is that web app framework. You do have to use pip3 install Bottle in order to make sure that works on your system. We're going to import route, run, request, post, and redirect. We're then also going to import the JSON module. So we're going to need this actually to be able to pull out the access token. Going to go over that in a couple minutes. And then we're going to import OS so that we can interact with the operating system. If we come down here, there's not a lot to this. We have a modem function here that I'll talk about in a second. We have a route to the root directory here, which is the message form. And then we have the post for the message send. So we have the form here. This is going to be the function to send the message, and then this is going to call the modem function to actually do a little bit more of the process. At the end here, this is basically just simply the line that you need to put in to actually be able to run the script as a web app. So run host at 0.0.0.0. So this means whatever your current IP address is, it will run at that. Port 80, again, since I'm actually administrator on my system, I can run this at port 80, so I don't have to do :8080 or anything like that. And debug equals true, because if there's a problem, I do want to see what the problem is. The first thing that we're going to take a look at is the route. So at route. So this is called a decorator, and this is a route decorator. So basically, this is the page that you're going to be going to. Page equals, so that we can put this on multiple lines and be able to format this decently. Single quotation, single quotation, single quotation, H1, message app, form action equals message send method post. So we're going to go to the message send page or script, right? And that is down here with whatever we put in. We're going to create a text area named message, 4 columns, 40 rows. Going to close that, and then we're going to have the submit form. So you submit the text, and then that is going to be sent to the message send script that we've created. Now you'll notice here the decorator says at post. So this is so that you can grab post values that are coming in. And so the post value is when you have an HTML form, the data is sent as a post. Message equals request.forms.get the message, right? So that text area we called message before. Basically, this is how we get the value from message. Print, so print out on the screen, message from or message from form, whatever the message is. If message does not equal none, send a message to the modem function. So again, one of the quirks is if your text area is blank, let's say you're doing troubleshooting or whatever else, you don't want to be sending blank messages. That's just bad for everybody. So if it's none, if it's not none, do this. So if it is none, don't do it if it's not none, right? Right. And then redirect back to our home, basically the root. With this, we're then going to go to the modem function. And if we come up to the modem function, this is where we get a little bit more complicated. Yes, there are keys here that will all be deleted before you watch this video. One of the problems when I do this, especially when I'm doing live demonstrations, is figuring out how to show you folks all this stuff while also keeping my keys hidden. And so basically what I just decided to do is delete my keys as soon as I'm done doing these videos. Anyways, we have a device ID. You get this from NoteHub. You get a project ID. You get this from NoteHub. You have the ID for the client and the ID for the secret. So the device ID and the project ID, this is what you're going to be sending to, and the identifier for you. This is what we're down here. This is what we're going to be using for that OAuth token. Here, we're going to get the OAuth token using F string, 3 quotation marks, just to make this easier. Curl post, we're going to be going to notehub.io for the OAuth, asking for the token. This is the application. Grant type equals client credentials, the ID for the client. So that's here, the ID for the client. Client secret, the secret for the client. The response is going to equal os.popenquery.read. So what this means is we're using the OS module. We're going to be basically running this query command, this curl. We're going to be running this, but we want to give the results back. So you can send the command without getting results back. We want the results back, and we want those results back as text, not simply an object, so we can read it. So basically, we're going to send this curl query. We're going to get a response back from the NoteHub servers, and then we're going to save that text as a response. That text is just text, though. We can't really access it the way that we want. So we want a JSON value. So then we're going to do is JSON.loads response. So that response value that came back as text, we're going to turn that into JSON. Token is then going to equal response access token. So the value of access token is now going to be token, and then we're going to print out the token on the screen. Now we're going to do the message. So we're going to print the message, so we know what's going on. The first thing that we're going to do here is we're going to get rid of single quotation marks and double quotation marks. So how you handle this is your own thing, because the issue is, right, we're sending this message through curl. Right, again, we got to think about systems and how all this different stuff is working. So we're sending this essentially through command using curl. If you put in single quotation marks or double quotation marks in that, again, when we're doing these F strings, things will fail out very quickly. So what I'm just doing here, to be very simple, is I'm simply eliminating the single quotation marks and double quotation marks, so we don't accidentally exit out of things before we're supposed to. Again, you might want to go into and look at how curl does escapes and that type of thing if you care about it. And then we have query. So query equals F string. We're using double quotation marks here because in the curl we use single quotation marks. Curl, we're now going to notefile.net projects, and then we're sending to the project ID, devices, the ID of the device, notes, data.qi. So there's different files up on NoteHub. This is the file that we're going to be sending it to. The authorization, the bearer, the token, so that the OAuth token that we got, we're going to be using here. And then we're going to send body, message, message. So again, remember everything has to be in JSON. So basically the body of what we're sending is going to have a key of message, and the value of message is going to be message. We have the double squiggles here because basically when you're using F strings, another squiggle escapes out of the first squiggle. Anyways, it's escape. The reason we have double here is because since we're doing JSON, we have to send squiggles, but squiggles actually mean something to F strings. So as to escape out of the squiggles in Python, we use an additional squiggle bracket when you're doing an F string. Anyways, then here we're going to do os.system query. So this is where you simply can send the command without getting a response, right? Up here, we needed the response so that we can get the access token. So that's why we did OSP open. Here, I don't really care. I just want to send. I don't want the value back, so I'm just going to send that off. Then I'm going to print message was sent and whatever the value for message is. And so basically, that is how the code for sending the message from my local web app works to be able to send it up to NoteHub. Now, in order to make this function, basically all you do is you hit the run button, right? So you hit the run button here, and you can now see that this is running. If I go here and I can say new message, I can hit submit. Then we come back here, and this is where we can see all of that printout message from before. So we get token information. So the token information is here. That's the token for this. We have new message. Message was sent, what the new message is. And so basically that information is being printed on the screen as a troubleshooting procedure. So now let's take a look at the code for the client system. So our little IoT messaging app right here. This is the Python, the bottle code that's running in order to get us this web page here. There are a couple of more modules that you have to deal with because you are dealing with that note card. And so that note card requires a couple of things. So from bottle, we're going to import route and run. That's all we need. We're then going to import SQLite 3. So you're probably going to have to install SQLite 3 onto your system, and that is just the database that we're going to be using. We're going to import OS module, and then we're going to import the note card module. So the note card module is a specific module that was created by Blues for interacting with the note card, and so this is where you're going to import it. From periphery, we then need to import I2C. So periphery is also another module that you're probably going to have to install. And what I2C is that it's an electronics communication protocol. It's actually an addressable protocol. And the idea is if you want to plug in a whole bunch of different electronic devices into an electronics project, this is a way that you can do that without having to run too much wire. So basically everything generally has a hard-coded address, and then you're able to communicate. So you can have multiple screens, you can have lots of different sensors, all of those things, and your electronics device is able to communicate with all of those different widgets. With this, again, if you're dealing with Arduino, you will deal with I2C a lot. With Raspberry Pi, you don't have to deal with it so much, but probably if you're going to be doing electronics projects, you will have to deal with I2C a little bit. And so for this, basically, we're just simply importing what you're going to be able to need for communicating with I2C. Now, one of the warnings here is make sure that you actually turn on I2C on your Raspberry Pi. So one of the weird quirks with Raspberry Pi is it allows you to do a lot of things, but sometimes you actually have to turn on whatever it is within the configurations. So the webcam, right? You connect up your webcam, and for some reason it doesn't work. It's because you haven't turned on the webcam within the configurations. There's a whole bunch of stuff like that with Raspberry Pi. One of the things that you run into is that if you do not turn on I2C, I2C doesn't work. So go into your configurations and turn on I2C. Then from datetime, we're going to import datetime just for a little formatting we're going to deal with later. What's going to happen here is when the script initially runs, we're going to set up everything that is required for our note card to work. The first thing is we actually have to do the I2C connection. So as long as I2C is turned on in Raspberry Pi, you should have dev I2C-1. So the port is going to equal this I2C-1. This is the address for it. And then in card is going to equal note card open I2C at the port with a couple of values. I'm not sure where those values are. Copy and paste those values. Anyways, this is how you connect to the note card. Product ID. So basically, this is your user account plus the project that you're doing. So I have an Eli the computer guy and a project of Pi because that's what I'm doing. And so that's the product ID. We're then going to be setting up the note card. And again, everything actually has to be in JSON. They use JSON to a hell of a degree. The request is going to equal a JSON value of request hub set. So we're going to be setting the modem here when we turn on this device. Request product. So the key in request is product. We're going to put in the product UID. So that's going to connect to our system and to our project. The mode is going to be continuous. So theoretically speaking, the idea is that the modem is going to be continuously talking with the network so that it can bring down any new information. You know, that's what they say. That's what they say. And then we have the request interval equals 2. So if we don't get new messages automatically down from their API, at least every 2 minutes, it should automatically try to sync with their API to bring the message down. Again, you know, whether or not that works, I don't know. I have some code to deal with that later. We have response. So RSP equals in-card transaction, the request. So we're going to send this request up to their servers, and then we're going to print out what the response is here. And so this is all just the basic configurations. Then the next thing that we're going to have is creating the database if it does not exist. So print create DB. Current directory equals os.path directory name, blah, blah. So basically this is so the database is stored in the same location that this Python script is in. Name equals message DB, file path equals os.path.join, current directory DB name. Connection equals SQLite 3 connect to the file path. Cursor equals connect con.cursor. We're going to create a SQL statement for create table. Create table if not exists. So this is one of the things I like with SQLite is basically you can run this command automatically on any new system. If the table doesn't exist, it auto creates the table. If it already does exist, it doesn't worry about it. We're going to have a table named message. It's going to have an ID column with an integer value, that's a primary key. We're going to have a timestamp from the note card column, that's text, and we're going to have the message, that's text. Execute create table. So it's going to run this SQL statement. If the table doesn't exist, it's going to create it. We're then going to commit. Do remember with SQLite, you have to commit. If you don't commit, you didn't do anything. And then we're going to close. Basically, I set this all up as its own function. And what you'll notice all the way down here is essentially when the script runs for the first time, these other things like with routes, this kind of stuff doesn't get called, but this will automatically get called. As soon as the script runs, this create DB function will fire off to create that table for you if need be. And again, you have the run host down here, 0.0.0.0. That's for this system. Just with the Raspberry Pi, I have it at port 8080 and debug equals true. So from there, so we've created the database, and we've got the system running. So we've connected to the note card, we set up the note card, we have the database, thing is running. So now let's take a look at the route for the root, right? So we have this to the root directory, so 127.0.0.1, this will show us our message, right? So I don't have to use anything additional in the URL, just 127.0.0.1. So here we're going to get timestamp underscore refresh equals message underscore get. So I want a timestamp value. So there's a timestamp value up here that says last refreshed. Again, just for troubleshooting purposes for people out in the field, they know the last time that the screen was refreshed if they're looking to wonder why they haven't gotten a message. And basically, we're going to have a return from the message underscore get function. Let's go up here and take a look at that message underscore get function. This is we're going to be getting the values from the note card. This right here is why this system works so much quicker than my Arduino system. So message.get fires off whenever basically the index file gets pulled up. So it's going to get refreshed every 5 seconds. So every time it gets refreshed, then this is going to run. This message.get function is going to run. And so the first thing that we're going to do is we're going to do a request of hub sync. So hub sync, this is where your Blues device communicates with their system and basically records any changes. So one of the reasons this system works so much better than the last one is it's not waiting on the continuous communication. It's not waiting on the interval communication. It's forcing this hub sync literally every 5 seconds, which may or may not be a good idea, right? So this is the request, command hub sync to do the synchronization, in-card command request. So basically, transaction is where you want to get a response. If you do transaction, you want to get a response back. Command basically just says, send the command, I don't want a response. Then we're going to create a request here, request, rec note changes. So I want the note changes to file data.qi, delete. So basically, if a new note comes in, I want the notes to be deleted off of the card. Because remember, it does not automatically delete notes off a card unless you tell it to. So I do want it to be delete. Print, request, response, in-card transaction, and then print the response. Then basically what we're going to be getting back is we're going to be getting back these JSON values. And so we're going to be looping through this basically as a multi-level dictionary. So for outer key, interdict in response.items. So we get this response back. So we want to get response.items, all the values. If message is in string of interdict, so basically if there is a message there, because that's all we want to care about, for key value in interdict items, so interdict is the values, and then we want the items of the interdict, print time, value time, message, value body, message. So that's all one thing. Insert, so db insert. So this is going to be where we're going to be inserting the values into the database. That's a different function. Value time, value body, and message. So we want the time that comes in from this, and we want the message that comes in from this, and we're going to be sending this to the db insert function. We scroll up here to the db insert function. We're going to print insert db time and message. So time and message are coming in. Current directory, we could probably clean all this out, but it's here. So the current directory, OS path directory name, database name, file path name, connection, SQLite 3 connect to the file path. Cursor is the same. SQL is insert into the message table that we created, timestamp note card, comma message, values question mark, question mark. Then we're going to execute the SQL statement. We're going to use the time value. We're going to use the message value. So that's going to be the SQL statement for the insert. Again, we do have to commit. If we do not commit, it doesn't actually stick. And then we're going to close that particular connection. So this is where we insert the values into the database. So we're going to come down here. Right, so that's where we insert the value. Then timestamp underscore refresh equals date time now. So the date time module that we had before, basically whenever this runs, I just want to get this value for the timestamp refresh, and then we're going to return that timestamp refresh. We're going to go here, we're going to go back to the index. So again, so now we have the timestamp. So we receive the message, we then insert the message into the database. We got our little timestamp. Then we're going to do record equals db select. So we need all the values from our database. So we're going to go up to this function. db select is here, right? Anyways, current directory, again, I could probably clean this up. Current directory, database name, OS path, connect to SQLite, and the cursor. SQL, the statement here is select all from message, order by timestamp note card, descending. So basically I want all the values from the message database ordered by the timestamp from the note card going from the closest to me back. So the newest to oldest. One of the interesting things with the timestamps is I've noticed sometimes with the communication, the order is different. So things will actually be in a different order. A message will be received, but it'll be at a different ID than you think it would be. So anyways, the timestamp, I think, seems to be the best way for being able to sort the messages. Cursor execute SQL. So we're executing the SQL statement. Record equals cursor.fetch all. So basically, record is now going to be all the records that came in from the database. We're going to commit. We're going to commit. We're going to close, and then we're going to return the value for record. So basically, all the records are now going to be returned as the value for record. We're going to have record page. So record page table. So we're going to open table. Table row, table header ID, table header timestamp, table header message, close table row. Oops. Close table row. Then for x in record, timestamp equals date time from timestamp x1 string blah blah. So basically what this is going to be is this timestamp here is, oh, I'm sorry. Oh, too many computers. This timestamp here is going to be this, right? See how it says like Friday at 10:43:05? So that's the timestamp that we're dealing with right there. So timestamp equals that, basically modified for day, hour, minute, seconds. So we're going to do record page. Record page equals f string, previously whatever's been in record page, tr x0, so this is the ID. Then we're going to do that timestamp that we created. Then we're going to do x2, which is going to be the message itself. So for x, so for every basically a record in that record that comes back, we're going to do x at index 0 will be the ID of the record. We're then going to print out that human readable timestamp that we created using x1, and then x2 is going to be the message. So at the third index, that's where your message is. Then you're going to close out the tr there. Record page equals record page, so basically what we created here, and then we're going to close the table. So again, whenever you're dealing with HTML, remember you open and close things. So we open the table here, we create the table headers, we then print out all the records within the table, and then we close the table there. We're then going to create a header, so meta, HTTP equiv refresh content equals 5. So what this is with an HTML5, you can auto refresh a page. So this is just within HTML5. It's not JavaScript or anything like that. Again, a very simple way of doing things. So basically what it's going to do is it's going to auto refresh every 5 seconds. So all those functions I showed you, every 5 seconds is going to auto refresh, and it's going to fire off all those functions to get the message, to insert the message, and then to select the messages. Then we're going to have a message app at the top. So that's where, if you take a look at this, again, this is the header part. Message app here. So that's message app there. And then last refresh, we have the timestamp refresh. So this is the timestamp refresh. So the timestamp refresh is the last time this entire page was updated, whereas the note card timestamp, that is the timestamp value for whenever the message came in from the note card. And then page is going to equal basically header, the header value, with everything that came in from the record page, and then we're going to return everything for that. And that is what gives us this little page that shows up when we go to 127.0.0.1. And that, my friends, that is the code for this particular project. So there you go. That is how you too can build your own IoT messaging device. And I will say with the quirks, as long as you're only printing HTML text out on the screen, this whole thing works like a champ. Again, you try to go watch a YouTube video, it goes to hell very quickly. But again, that's one of the big things. When you're thinking about systems and when you're thinking about actually, building solutions, there's all of these different things that come together to build a solution, right? There's the code, the Python, there's the product that you're buying, there's the API calls, there's the hardware itself. If any one of these things fails or is quirky, oh, the entire thing is a disaster. But again, for just this actually works well. And again, this could be a messaging device, again, in, things like field technicians' vehicles. This could be, digital display. So you could have CSS in order to make this prettier, different colors and that kind of thing. You could store images locally, so you cannot send images or movie files or anything like that over Blues. That's just not going to work. But you could store them locally and then basically trigger them or point to them based off of current conditions. That's where, like, let's say you had like a little weather app here. Like if you have an iPhone and the weather is going to be rainy or the weather is going to be sunny, you know how the image in the background changes? Well, what you could do is you could have the same type of thing on your device. So you could have a rainy image and a sunny image and a cloudy image. And then if the weather is going to be sunny, you simply show the sunny image that's already on the device. You don't have to send the image to the device, it's already there and you simply reference it, right? That's some of the interesting stuff that you can kind of do with this. And again, like it's like I say, if you're dealing with digital billboards and campus facilities or that type of thing, someplace where you can have access to the local storage. So it's like I can gain access to the local storage to put in a new USB stick. I just don't want to do it every day or every week or every month, right? So I could be like an IT person, basically clone, 30 different USB drives, and then once every month or two, simply go to all my different digital displays, plug in the USB drives, and then when I send new messages to all those displays, it will be able to pull, from the local graphics files that are on the device. Again, this is the type of thing that you need to be thinking about with this whole concept of architecture. And again, in this IoT world, what happens when TCP/IP4 high bandwidth connections simply don't exist? Can you more or less get the same results by designing a different architecture, a different way of doing the communication? Maybe it's a little IoT modem, maybe it's a little bit of sneaker net, maybe it's a little bit of some other things. This is the kind of stuff that I want you to be thinking about as modern, computer people, modern technology professionals. So, anyways, yeah. Again, with this, I'm very happy with blues. If you watch my videos, you will know I was very frustrated with blues before. Using the blues dev kit. Using the blues dev kit. Yep, the dev kit definitely exists. Oh, boysies. Anyways, being able to use Python and using this on a Raspberry Pi, I have to say this whole system works so much better. And again, one thing to be thinking about when you're designing these types of systems is what do you really want? Like a lot of people think, well, a microcontroller is going to be a lot less expensive than a Raspberry Pi, so I'd want to go with an Arduino or microcontroller. But remember, Raspberry Pi has the Raspberry Pi Zeros. The Raspberry Pi Zeros are down at like $10 a piece. So you could actually get a full-fledged computer that can run Python that you can plug this hat into that might be a much better development environment for you, again, for 10 bucks versus, going down the Arduino route. So that's going to be the other thing that you need to be thinking about, again, as a professional when you start deploying this type of thing, is like, what is your knowledge? What is your comfort? Are you more comfortable with Python or with Arduino, that type of world? And then also institutional knowledge. Do remember, when you start designing this type of thing, at some point you're going to leave the company. I don't know whether it's going to be a heart attack or you're going to get fired or you're going to get a better job, right? At some point, you're no longer going to be working for that particular company. So one of the things to be thinking about is the institutional knowledge of your company, what other people in your company know. So again, if you're in an environment where you're dealing with microcontrollers all the time, so it's not just you, but your peers are also dealing with microcontrollers, then it might be much better, again, to be in that Arduino world. On the other hand, if you're in an environment where people are more, again, in the Python world, doing back-end infrastructure, building web apps, that type of thing, it might make a lot more sense to design your solution for Python so that when you leave the company, for whatever reason, somebody can actually pick up your code and have a chance in hell of knowing what's going on. Again, having done projects in Arduino versus Python, I know personally for me, I feel a lot more comfortable in Python and I feel a lot more confident with what I'm doing in Python, even though I'm pretty sure what I did in Arduino was solid. Pretty sure. Pretty sure. Again, I code like an MCSE. Let's be clear. Let's be completely clear. I code like an MCSE. But I'm pretty sure what I did was solid, but I don't have the confidence that I do that I have with Python. So again, this is another thing that you need to be thinking about when you start deploying these types of projects. So anyways, with that, I think that's about all I've got to say. As always, I enjoy teaching this class, and I hope to see you at the next one.